Hey guys, yeah, welcome back to my channel. Today's JAMB house day, I have this video prepared for you. For those of you that are having issues with organic chemistry, this video is for you. And if you are the type that you don't have a depth knowledge or you don't have a background knowledge of organic chemistry before, I will advise you to check my full video on introduction to organic chemistry in my catalog. So today we want to extensively look at the kind of question they can come across with in organic chemistry. And many students out there, your tutor might be telling you that you'll be coming across naming. Yes, you come across naming, but not the kind of naming you think you come across. So guys, look at what you have on the board. They said how many isomers of C4H9OH. As a science student or as a JAMB, being a teacher or being a tutor, I know this is a what? A butanol acid. Because we have 4 carbon atoms, a what? A butanol. We are not here to show you guys that our A is A. I'm here to explain why A or B or C or D is the answer. So guys, they said how many isomers of C4H9OH will be tertiary alkyl? Yes. How do we determine it? It is very what? Simple. The first thing you should know is that if you are given a question or a related question to this, you should be able to tell which one is butanol, propanol, hexanol. If you can easily identify the compound, that means you know what you are doing. So guys, C4H9OH is what? Butanol. So I will explain the primary alkyl, the secondary alkyl, and the tertiary alkyl. How can we easily determine it? It is what? Very simple, as I've said earlier. If you are given this, this is a good example of what? Primary alkyl. Are you with me? If you have this R prime, so we have H. This is example of what? Secondary Are you with me? If we have this, okay. Now, so we have tertiary what? Alkyl. As you can see this arrow here, alkyl group, where we can have our methyl, ethyl, propyl, butyl, like that. So guys, the arrow here shows I have 2 alkyl group attached to this. We have 3 here, 3 alkyl group attached to this. So guys, according to the question, how many isomers of C4H9OH, which are identified earlier as what? Butanol. So guys, the first thing we are going to do is that draw the molecular formula of this. With that, I can say, so permit me, I'll be what? You know many of all these already. So I'll put this here. Arrow is equal to alkyl group. Primary, secondary, and what? Tertiary. In case you come across it. So now, this we have carbon 1, 2, 3, 4. So we can have CH3 here, CH2 here, CH2 here, CH2OH. So what do you have? A 1. So when you name it 1, 2, 3, 4. If you are naming a compound that has a functional group being attached to it, either OH, either COOH, which is carboxylic, either CHO, which is alkanal, either CO, which is alkanol, either COO, which is alkanoate. You always number from where you have the what? The functional group. So here we have, it is called butan 1-O. Are you with me now? This is a primary what? Alcohol. So let's show that. Let's see. All what you have here, you can see. This is the carbon. The R, like this, is what you have here. Why this arrow is this? Are you getting it? So the next one is what? Secondary. So let's see if we can have a what? A secondary alcohol from the compound given to us. So we have this C so this arrow goes to CH3, CHOH, CH2, CH3. So let's count if we can have 9. Let's go. 3 plus 2, 5. 5 plus 1, 6. 6 plus 3, we have what? 9. So we are getting to so this now. When you number, I told you guys earlier that you number when you have the smallest number being attached to the substituent of the functional group. So we have 1, 2, 3, 4. That's from our left hand side. From right hand side, 1, 2, 3. 3 is being attached to OH, but here we are having 2. So it is called butan 2-O. This, I call it sec butyl alcohol or alkanol. Are you with me? So that is, this is not the answer. I'm just showing you guys this explanation in case you have a question relating to this. I want to answer it. So the next one is, can we have another isomer under this? Initially, they said how many isomers of C4H9OH will be tertiary alkanol. So the next one we have this. Sorry. So let's count. 3 plus 3, 6 plus 1, 7, 8, 9. The carbon atoms, 1, 2, 3, 4. We are getting there, and the OH. Are you with me now? So let's go back to this. This is R. This is what? R prime. Why this CH is what? Are you with me now? So this one is called isobutyl alkanol. Or let's count. 1, 2, 3. So we have 2 methyl is 3 propan 1 O. So let's take the last one to see if we can have a tertiary, because all what you have here now, they are what? R. Are you with me now? So guys, the last one I have CH3 OH CH3. So let's count the number of carbon atoms. 1, 2, 3, 4. Okay, this 3 plus 3, 6 plus 3, 9. This, and here is our OH. Okay, we are getting there. So guys, if we are to name a compound like this, it is very, very what? Simple. Are you with me now? So you count either from right or left. These two will still be adding to what? The functional group. So that will give us propan. Sorry, the methyl force 2 methyl propan 2O, or we call it tet butyl alkanol. Are you seeing the name now? You can see that tet means what? Tertiary. So guys, let's go back to the question. states how many isomers of CH4H9OH will be tertiary alkanol. That is, it is very simple. 3 alkyl is being attached to one carbon atoms with what? OH, which is this. This is one R. This second R prime. This is what? The third what? R prime prime. Are you with me now? So we can see that we have this alkyl. I told you guys earlier, this is alkyl. This is also what? Alkyl. Are you with me now? So the answer is 1, because in butanol we can only find what? 1 tertiary alkanol. But if the question goes those that how many isomers is butanol, we have 4. 1, 2, 3, 4. Are you with me now? That's the answer for that. So let's take a look at this question you have on the board. The formula CH3 in the bracket, you have a 3COH, is that of A, or an alkanoic acid, primary alkanol, secondary alkanol, or tertiary what? Alkanol. So let's take a look at this now. We have CH3, we have 3 here, COH. This is equivalent to CH3 in 3 places. The carbon at the middle here, we have CH3 here, we have CH3 here, we have what? OH here. When you look at this question, this is also a JAMB question. Sorry for not. So this is JAMB 2020 question 34. If you are with a past question, take a look at that. JAMB 2020 question what? 34. When you look at this here, class, and what I explained earlier under the alkana, you can see that we're having the same thing, which is what? The formula, this particular formula is a good example of what? A tertiary alkana, which is this. Are you with me, class? So let's quickly look at another question before we call this class today. So this question goes thus. So please take a look at this very well before I go up off the board. So go. So the question goes thus, states, number 3, which of the following can undergo addition, reaction, and substitution reaction? A, benzene, B, pentane, C, propane, D, hexane. So this is what? JAMB 2023 question 30. So let's take a look at the fourth one. The way I always do it, this one is very, very what? Simple, but need full explanation. The following are miscible, wow, with water. A, ethanoate, B, ethanol, C, ethanoic acid, D, methanol. So guys, let's take a look at this, then we can have the end of the class. This is also JAMB 2020 question 16. Look at this now, class. So the question goes thus: which of the following can undergo addition and substitution reaction. And when we talk about addition reaction, it means the reaction from a double bond, listen attentively, from a double bond reacting with a catalyst that will give us a what? A single bond. When we talk about that's a what? Unsaturated hydrocarbon. That's for addition reaction. While substitution reaction, they are saturated because it can easily react with a compound, just like a reaction between methane and chlorine in the presence of sunlight. That's what a good example of substitution reaction. So when we talk about substitution reaction, the saturated hydrocarbon, methane is saturated. Why? Because it's a single bond. Propane, saturated because it's a what? A single bond. Hexane is a what? A saturated because it's a what? A single bond. While benzene is alternates with single bond and double bond. So this pentane and propane and hexane can only undergo what we call substitution reaction. But benzene can undergo both addition and substitution reaction. So guys, our answer is what? Benzene. The last one. The following are miscible with water: ethanoate, ethanol, ethanoic, and methanol. There is one relationship between this compound you have on the board: ethanoate, ethanol, ethanoic, and what? Methanol. So this is it. Let's quickly look at what we call reaction between carboxylic acid plus hydroxy will give us esters plus water. So let's take a look at it now. This carboxylic now, this hydroxy. This hydroxy is more, okay, we have this. Let me show you guys the little mechanism. We have this. So this structure for carboxylic, double bond, O, OH, and A. So this will react with this to form water, while this we have what? R, this double bond, and we have what here? O. What do you have in class? R. This is what? Example of what? Esters. They are called the alkanoids, which is derivatives of what? Ethanoids. So this is the question goes us. When we talk about miscible, you know, when you get a liquid that is being mixed with another liquid. For example, now you have a carbonated drink. Are you with me now? I got a fruit orange juice. When you pour the orange juice inside another liquid, are you getting it now? You see a particular reaction. You have, it's somehow light, just like I'm guessing you have a fruit juice. They pour water inside that fruit juice. That the color of the fruit juice will not change. Rather, it will have, we just see it light. That is, a liquid can easily dissolve in what? Another liquid. That's what we call immiscible. So class, ethanoate is not immiscible in water. Are you with me now? But ethanol, ethanoic, and methanol, you can see now, these two and these, they belong to the family of what? Hydroxy, the alcohol. Why this ethanoic belongs to the family of what? Carboxylic. Ethanol, ethanoic acid, and methanol, they are miscible to water. And they are polar solvents. They can easily. Are you with me now? So the answer is what? Ethanoate, because it is not what? Miscible in water. The way you approach your question in JAMB, you might understand it fully, and at the end, you miss it. So you need to understand the question, understand what why A is A, why B is B, why C is C, and why D is D. So guys, don't forget to subscribe to my channel, like, share among your colleagues, and do it to drop any question you're having issues with in my comment box. Thanks.